When we've been using the completing the square method in solving quadratics, have you noticed that the leading coefficient has always been a 1? And I hope you can remember, based on that original picture that we drew that first corner of that square as an x times an x squared. And that allowed us to build a perfect square. From here, this example, my leading coefficient is a 9. So my first step in order to solve this equation by using the completing the square method is I need to ensure my leading coefficient is a 1. So how do you suggest we do that? Yeah, you're right. Let's divide both sides by a 9. So the right side divided by a 9, well, that's just a 0. The left side becomes an x squared minus a 6/9 minus a 4/9. And then that middle term, that 6/9, that can reduce down. So let's reduce it down. So I have x squared minus 2/3 x minus 4/9 equals 0. Now, this step right here and this step, well, actually all three of the steps, they're all equivalent expressions. This one's just an equivalent expression reduced by a factor of 9. But the bonus for us is my leading coefficient is a 1, which means I can solve it with completing the square. So to do that, we want to get all the terms with x's on one side. From here, I want to include a magic number, basically fill in that last corner piece to figure out what that number is. And how we did that, we took the middle term and halved it. And so we have a negative 2/3 divided by a 2. And that equals negative 2/6. Yep, negative 2/6. And then we want to square that. And that equals equals positive 4/636, and that equals 1/9. So it turns out then, I lost my spacing here, so x squared minus 2/3 x plus 1/9, that's the perfect dimension of that corner piece, makes this a perfect square. Then from here, I have to add it to both sides, so I have a 4/9, which I originally had, and plus additional 1/9. Again, because I add something to one side of the equation, I need to add it to the other to maintain its equivalence, maintain its balance. The bonus of looking for this number, it turns it into a perfect square. And in this case, it's x minus and the square roots of that, which is 1/3. Equals on the right side, looks like I have a 5/9. Using the square root property now allows me to take the square root of both sides. So x minus 1/3 equals plus or minus the square root of 5/9. And from here, it's just a matter of getting x completely solved by itself. So let's add 1/3 to both sides. And now I need to simplify because you notice that I have a radical in the denominator. And you remember what that did? That was 1/3 plus or minus the square root of 5 over the square root of 9. And there, from there, I think you can see where we're going. That equals 1/3 plus or minus the square root of 5 all over a 3. And there's my final solution. Some people might combine them, add them together, and make it a 1 plus or minus a root 5 all over a 3. But both those final two are equally equivalent, equally simplified. I'm fine with either one. As long as you can understand and you can remember that there's two solutions here. One is 1/3 plus root 5 over 3, and the other one is 1/3 minus square root of 5 over 3.